Class 12th Chemistry, Chapter 11 Alcohols, Phenols and Ethers. Today topic is Preparations of Phenols. YouTube channel Plreddy Chemistry JEE NEET for material Chemistry for IIT JEE NEET. Blogspot.com.
Preparations of phenols. Phenol is also known as carbolic acid, benzenol and hydroxybenzene. In the phenol, OH is attached to sp2 hybridized carbon. Next, preparations. General methods of preparations. The first one, from benzene sulfonic acid. When sodium salts of benzene sulfonic acid is fused with sodium hydroxide, phenol is forming. This is the sodium salt of benzene sulfonic acid. In the class 11th, we learned how to prepare benzene sulfonic acid. The benzene react with concentrated sulfuric acid, we will get benzene sulfonic acid. Now we are reacting with base, so it is forming into phenol. Now from benzene diazonium chloride, this benzene diazonium chloride also came in the aryl halides. Benzene react with NaNO2 plus HCl. The stable intermediate is benzene diazonium chloride. From the benzene diazonium chloride, we can prepare many compounds. In that, the phenol also one of the component. What we are doing here? Steam distillation. Steam distilled. So we are getting phenol. So in the last class, in the aryl halides, we prepared from this benzene diazonium chloride, chlorobenzene, bromobenzene and cyanobenzene and many other components we prepared. From chlorobenzene. Now, from the chlorobenzene, this, if you want the phenol, you can remove this chlorine. But this chlorine removing is very difficult. Why? Because here resonance structure is there between, see here this structure, chlorine and this benzene is there. This lone pair is given to benzene ring. So in between chlorine and benzene, pi bond is forming. So due to this double bond nature between chlorine and benzene ring, this is the chlorine. So this bond cannot break up. So that is the reason here nucleophilic substitution cannot takes place easily. But in case of alkyl halides, easily with aqueous NaOH we can make alcohols. So these reactions we discussed in the alkyl halide chapter, especially in SN1 mechanism and SN2 mechanism. Those are very important in that chapter, SN1 and SN2. So here one star mark this one. In the first step I said it's not possible to make phenol from chlorobenzene, but here the phenol we can make it, but that is in extreme condition. Aqueous NaOH at 200 atmosphere and 300 degrees Celsius, 200 atm and 300 degrees Celsius. It is very rare case. And next, order of nucleophilic substitution reaction. So in the chlorobenzene, here ortho nitro and ortho and para nitro, then two ortho positions nitro and one more para position is there. So whenever these ring deactivating groups are there, nucleophilic substitution reaction rate is increasing. See, first of all, what is a nucleophile? Means electron excess compound. If electron excess compound, where it will attack? Where the less electron density is there. So in the benzene, generally pi bonds are there, more electron density is there. It is not ready to attack on the benzene ring. But whenever NO2 groups are there, these NO2 groups are electron withdrawing groups. So then the nucleophile attacking nature is increasing when electron withdrawing groups are present. Here only one group is there, here two groups, here three electron withdrawing groups are there. So more reactive towards nucleophilic substitution reaction. Next, from cumin, this is a very wide production is giving. Most of the world production of phenol is from cumin. Phenol is manufactured from the hydrocarbon cumin. Cumin, another name is isopropyl benzene. See, this is the isopropyl benzene. This is the isopropyl benzene. Is oxidized in the presence of air to cumin hydroperoxide. Cumin hydroperoxide. It is converted to phenol and acetone by treating it with dilute acid. Acetone, a byproduct of this reaction. This is the acetone. It is the byproduct of the reaction. See here the doubt a few students ask that, so why oxidation takes place in this hydrogen only? Why not these terminal hydrogens? So here the benzyl carbocation is more stable, this hydrogen is more acidic. So here oxidation takes place. Medium, the protonation takes place. In acidic medium, protonation takes place. This hydrogen will come here. So it is a oxygen plus. So this pi bond, sigma bond shifted to here. It is releasing as a water molecule. It is releasing as a water molecule. Then this oxygen is getting positive charge. So this one will attack on the benzene carbon. Next, obviously this carbon becomes, this bond is shifted towards oxygen, we have to show. Now this carbon is getting positive charge, carbocation. So at this carbon, the water molecule वापस attacking on the, this water molecule attacking on the carbocation and forming, it is the ketone. So now in the mechanism, if you keep the star mark here, this star mark, first oxygen is going to benzene, the second oxygen is going to ketone. This is the important here. Next, show how are the following alcohols prepared by the reaction of a suitable Grignard reagent on methanol. So to prepare primary alcohol, we have to take formaldehyde, HC double bond OH. Now a remaining part will come from the Grignard reagent. That means this remaining part will come from the Grignard reagent. What is the Grignard reagent? We know that RMGX. So here R means isopropyl magnesium bromide or magnesium chloride. This one is formaldehyde. These two are the reactants. Then here this one total cyclohexane is coming from Grignard reagent. Next, write the structures of the products of the following reactions. See here the first question, addition of water molecule according to Markovnikov rule. This OH minus OH goes to where less number of hydrogens are there, and H plus will attack here. Of course, H plus will attack first, that's why it is also known as electrophilic addition reaction. See, this is the product. It is the Markovnikov product. Markovnikov product. Next, Markovnikov, MK we can say. Next, in the second, see, sodium borohydride. Sodium borohydride is the specific reducing agent. It can reduce only aldehyde and ketones. So here the ketone functional group is there. So obviously this ketone will reduce. It is not the ketone, this is the ester. Okay. So this is the ester. Ester cannot reduced by sodium borohydride. So the product. Next, third one, there is no only one thing here, functional group, only one functional group is there, it will reduce to alcohol. You can see here this double bond becomes single bond, and OH ester there is no effect. Next, this aldehyde becomes alcohol. Here reduction is there, here reduction is there, the remaining structure as it is. Physical properties, that boiling point. The boiling points of alcohols and phenols increases with increase in the number of carbon atoms. See, boiling point always directly proportional to the molar mass, molecular weight. So when number of carbons are increasing, molecular weight is increasing, that means methyl alcohol to ethyl alcohol boiling point increases, ethyl alcohol to propyl alcohol again boiling point increases. But the second point here, but decrease with increase of branching in carbon chain. So whenever branching is increasing, the surface area is decreasing, so boiling point is decreasing. Next, boiling point of alcohols and phenols are higher in comparison to other classes of compounds like hydrocarbons, ethers, haloalkanes and haloarenes. Comparatively, these functional groups or compounds, alcohols boiling points are higher. Due to, what was the reason? Due to intermolecular hydrogen bond. See this red one. This is the intermolecular hydrogen bond. As well, see here three examples. The first one is alcohol, and the second one ether, the third one is hydrocarbon. See here, in case of alcohol, 351 Kelvin is the boiling point. In case of ether, 248, almost 100 variation. Here ether and hydrocarbon little variation is there, but decreasing. See, when we are taking these boiling points, we have to take almost equal molecular mass. See here 46 molecular mass, 46 molecular mass, here 44 molecular mass. Next, solubility of alcohols and phenols in water. Solubility of alcohols and phenols are higher in comparison to other classes of compounds, namely hydrocarbon, ether, haloalkanes and haloarenes, due to their ability to form hydrogen bonds. In the last point, due to the hydrogen bond, boiling point was more. Same reason, due to the hydrogen bond, here solubility also higher compared to other functional groups. Next, the solubility decreases with increase in size of alkyl or aryl group. When methyl alcohol and if you take phenol, in case of methyl alcohol only one carbon is there, in case of phenol 6 carbon chain is there. The 6 carbon non-polar carbon chain cannot dissolve in water, That is the reason the solubility of alcohols decreasing by increasing size of carbon chain. Next, the lower molecular mass alcohols are miscible with water in all proportions, like methyl alcohol, ethyl alcohol, those things. Now the question is, arrange the following sets of compounds in order of their increasing boiling points. The first question is pentane 1-ol, butane 1-ol, butane 2-ol, ethanol and propanol and methanol. See, सबसे least we can say methanol, then prop and ethanol second one, then it's a better propanol third, उससे better. Here two butanols are there, butane 1-ol, butane 2-ol. Butane 2-ol is the branched type, so 3, then 4 is a better. This one is 5, this one is the 6, highest boiling point for pentane. How you have to write? See, number of carbons is the first preference. If a carbon chain is same, then we have to consider surface area. Next, if surface area is more, then boiling point is more. Surface area, how to calculate? So just simple branching or simple molecule we have to check. If branching is there, obviously surface area is less. Next, pentane 1-ol and butane and pentanol and ethoxyethane. This is the ethoxyethane, means ether, the pentanol aldehyde, this is the alkane, these are the alcohols. Obviously सबसे highest alcohols होगा, butane सबसे least होगा. Next, ethoxyethane and pentanol ये बीच में, you can see here N-butane सबसे least, alcohol सबसे highest, then बीच में pentanol and ethoxyethane. Obviously pentanol is more because the number of carbons more.
Thank you. Next class is chemical properties of alcohols. Don't forget to like and subscribe the channel.